This is Muhammad Ghous, and this is the quantum relativity, in which we discuss the wave nature of graviton as it is a particle, and according to the de Broglie hypothesis, every particle has a wave and particle nature. So let's explain it. But first of all, let's apply the Hamiltonian operator on it to describe its wave particle nature. Like we are talking about graviton. So the graviton is basically here a spin tube with contracted components depend upon the constant value. So let's see how it looks like. It looks like something like that, partially changing the wave function of the graviton with respect to the superpositional time, which is stating that the graviton particle moving, let's say, in a wave or in a particle nature, and within its superpositional absolute time or collapsed wave function collapsed time observed by the fine frame, how it is changing with respect to its superpositional wave function's collapsed time. And that's how it works, and it travels in the form of waves and frequencies. But how we can define it? Because basically, this equation is simply describing the wave function of graviton as a wave in the consciousness or in the thoughts of the final frame as a wave. Describing that this is maybe imaginary. So we have some equations to define it, like the de Broglie wavelength, h by e. Now, as we all know, steam UV is basically a reduced version of momentum, because it describes momentum, but it is a higher dimensional. It describes things higher dimensionally, so that's why we reduced it or make it equals to the momentum of that particle. Because in a particular graviton, if let's say this total the mass averagely moving within that graviton, describing the momentum of that graviton, and that's how we and that's why we call it the quanta of existence. So by applying this concept here, what we get something like that, equals to h by t mu v, and hence we all know t mu v equals E n g mu. By neglecting the dark energy, because as I discussed in my previous lecture 3, dark energy is nothing but the combination of two gravitons with each other. But for now, we are talking about a single graviton with a particular dimension. So we write it here like that. And that we have derived the wavelength of graviton particle, that how it moves, with how many wavelengths it will move in the thoughts of the fine frame. The more bigger is the frequency, of course, uh, the more smaller the frequency is, the more higher the dimension of graviton we are talking about. And that's the reason gravitons are less interacting, as it is defined in the string theory, that the strings will vibrate mo- mo- uh, the, the, the more the strings will vibrate slowly, the more the higher dimensional graviton we are talking about. It increases the more slower the string's frequencies. Now let's talk about, now we have derived the wavelength, and the Schrodinger equation also defines the energy, which is basically equals to the total energy or within that dimension of graviton, and that's what Hamiltonian operator defines. So it defines nine things collectively. So anyways, let's talk about the frequency v by the wavelength. So As we all know, the gravitons move with the speed of light as they are massless. So the whole equation becomes something like that. So let's see, we have graviton particle, wave function, and by h, because we have substituted the wavelength, which is written like this, giving us the frequency of the graviton. Now, the more, the bigger value of the frequency, or the higher the speed of the graviton moves, it means the higher the bigger is that graviton, or the bigger it has dimensions, or the bigger it has dimensional values. Let's describe it in terms of energy wave theory. E equals hf. Now it's time to define it in that way. So if we explain it in this way, it looks something like this. Like, first of all, we have described the frequency, CEN by H GUV, the wave function of graviton, and now E equals hf, describing how energy is converted into wave. We can define it like this by substituting the frequency of gravity. We get something like that. It is stating that this process is describing the graviton, and this is describing the speed of light, and this whole term is equal to the energy of graviton, describing the energy of graviton. Now, let's talk about entanglement and infinity. Now, as we have discussed, that this is how graviton will move in the thoughts of fine fields. But in how it defines entanglement, and what is the reason it will move with the speed of light? Because at the speed of light, the first thing, the graviton is massless, and the second thing, at the speed of light, the time becomes zero due to time dilation, and that's the reason no time exists in the thoughts of fine frame, as it is itself a space-time, making timelines within the graviton. The more bigger or more the graviton has dimensions, the more it makes the timelines complex with complexity. But is there any distance term in between these two lower or high dimensional gravitons? Of course not. But they will move in terms of frequencies. Like in string theory, it vibrates, and every vibration gives rise to a graviton. Similarly, every wave with a different frequency or higher frequency gives rise to higher dimensional particles, and lower dimension or lower frequencies give rise to lower dimensional particles, like our 5% universe. So now let's talk about entanglement and the reason, and let's talk about the reason why entanglement happens at the speed of light. Now, entanglement, as you all know, why lower dimension, higher dimension observes lower dimension. This is because these are entangled. As simple as these are created with the same frequencies and with the same material, you can say that. That's why they are entangled with each other. Dimensions are basically entangled with each other, as dimensions are basically nothing but space-time gravitons, or curved space-time called gravitons, and that's how they're entangled. And this process happens at the speed of light because these frequencies move at the speed of light, but as we only uh, experience its particle nature as it is observed by the fine frame, but still it is moving in the form of waves, as the wave nature of photon, the wave nature of electron. Similarly, it is the wave nature of graviton. Now, and this is how, and that's the reason basically that at lower dimensions, macro level objects like Earth, Sun, a box are affected by higher dimension observations, and the reason is that they are entangled, and that's why normal entanglements and lower or higher dimension happens or occurs at the speed of light. Now let's talk about multiverse. So the multiverse is nothing but in the thoughts of fine frame different frequencies, and they sets different same frequencies like this is an energy level of this wavelength, particular wavelength and particular frequency. Similarly, this is a set, and there are total 7 maximum sets. And as we are moving in lower to higher dimension, it is exponentially increasing. But when we are talking about this relation, the Gauss constant here and the graviton, this it exponentially increases 85 plus 85, like in the example of the lecture 2. In lecture 2 we have discussed for a vector to come into a 4 dimension it is 171, and for a 4D to transfer into a 5D it is 6.2. And now when we plus the 171 we will get 256, but the Einstein constant is 2.070 multiplied by 10 power minus 43, or in positive way it looks like something like this. But this exponential law is not applying here. Well, what's for the reason? The reason is that we are vectors, mu and v. We are vectors, and if we apply a double jump like 4340 plus 85 plus 85, then it will convert into 256. It's simply stating that it is a complex of two vectors. As we are vectors, and to convert into a 5D, first of all, we have to jump from our dimension and then to jump from the 4D, because in Einstein equation describing that 3D is affecting 4D, and that's the reason we have written it like this, and that's the reason the vector needs a double jump, one for their vectors and one for the 4D, making collectively the 256 jump. In other sense, it is simply stating that you can write 7.33 multiplied by 10 power minus 171 or 2.070 multiplied by 10 power minus 43 as the same, because it is describing mu v and it is describing the contracted mu v at mu 0. A single variable to convert how we can jump from lower to higher. This is the energy level and this is the jump, like 43 plus 85 plus 85. And then if we double the jump of exponent, it simply comes up into 5 dimensions. Alright, now let's talk about infinity. Now, what is the limit of the fine thoughts of the fine frame? Well, the answer is it is infinity, but for now, how much the fine frame has thinked is the value of infinity. Basically, in my hypothesis, I explain infinity as a variable. Like, it depends upon how much the fine frame thinks. Like, for now, the maximum bigger graviton with high dimension is that striving the infinite value here. And if you're talking about 1 by 0 or any other cases, now in this case 1 by 0, in the case of 1 by 0, if we simply state that 0 is approximately equals to t mu v and uh, n like this. We have the limit for now this. Or in other words, if we apply or make the zero superposition, because as I have described in my previous lectures that there is a superposition in existence and non-existence. These are superpositional states. Means, let's say uh, a chair is in superpositional state. Let's say after some observation it becomes a book. Means there is a superposition in the existence of that chair. But as we have experienced in our daily life, it does not change as it is observed by some final frame. So if we make the zero, because zero is nothing but just an illusion we have made, if we made zero superpositional, it is basically describing the reality. You get something like 1 or some values smaller than 1. As if you apply 1 here, it becomes 1. If you apply 1 by 2 here, it becomes 0.5, and that's on. The series goes on. But it's a wave function. Now, let's talk about the last lesson, wave functions and gravitons. That is there an equation that describes final frame? Yes, there's an equation which is this, that alpha beta till n wave function is equals to x mu v n minus 1. Now, by describing the final frame, it becomes an inequality. But why? It is stating that after observing the wave function, its realities change, like in the thoughts of the final frame. And that's how we describe final frame. But for now, if we are talking about final frame, we don't use term dimensions, because to make final frame taking decisions, you have to make final frame outside the space-time, and this is the only conclusion, so that the final frame will control the existence and non-existence of space-time. I mean, what if the final frame is in the space-time? This thing happens like this is the space-time bubble of some n-dimensional space, and here's the final frame. Now the fine frame is living in distance, means that distance and time exist, means he has to follow the nature of time, the nature of space, and hence there may be more than two fine frames. So for this paradox, we have the conclusion that fine frame must be one and outside the space-time, but the thing he is observing must always has dimension lower than the fine frame, and the limit is n equals 9, 9 indices. So in the lecture 5, we'll talk about the 1-inch equation. Thank you.